Thank you very much, David. I appreciate it. Like David said, my name is Leah Duzy. I work for USDA ARS in Auburn, Alabama. I'm with the National Soil Dynamics Lab. We have several different groups here, but I'm part of the Conservation Systems research team. And so this afternoon, I'm going to be talking to you a little bit about what we define a conservation system is, how that relates to soil health. Also, why are conservation systems important in the Southeast? In particular, that's where our research really focuses on. Also, what barriers continue to limit the adoption of these systems in the Southeast? And then how are we addressing these barriers here at the National Soil Dynamics Lab, as well as across the country, where scientists, both with USDA and with the universities and other groups, are doing research currently and have been doing research to address these barriers and other concerns related to conservation systems and cover crops and other soil health practices. So with that, what is a conservation system? So when we're talking about a conservation system in our research, we include a high residue cover crop. And when we're talking about a high residue cover crop, we like to see over 4,000 pounds per acre of biomass. We really like to see upwards of 8,000 pounds per acre of a high residue cover crop for weed control in particular. So we have our cover crop. Most of our research has been with single species, like in this picture. This is a cereal rye. Renza Bruzi is the variety. That's our preferred variety here. And then we've also done some work with crimson clover, and as I'll discuss in a little bit, we have some mixture work going on currently. So we combine that with conservation tillage. This could be no-till. It could also be strip till, as shown in this picture. You'll see the residue from the cover crop, and you'll notice there's a strip here going down behind the tractor, and that's a strip till. And then the producer would come back and plant into that strip. So there's very, very little soil above ground or on the soil surface. It's a non-inversion tillage. And so that for us makes up a conservation system. So why is a conservation system important in the Southeast? We'll move on, and this really complements the maps that Maria put up earlier, and I'll talk about that a little bit. The soils in this region, so if you look in the Southeast, this would be the orange color here. Those are predominantly ultisalts, which are characterized by coarse soil textures, poor structure, and organic matters that are usually below 1%. And so obviously these soils could certainly use some improvements through the use of conservation systems. Maria's maps earlier on no-till and cover crops really set this map up nicely. The two blue circles here are where we have a large proportion of our producers using no-till in the north of Alabama, and then using some sort of conservation tillage in the south, whether that's no-till, strip-till, or some other minimum tillage, where they would leave 30% residue or more on the soil surface. And then when you add in cover crops, it really overlays nicely. In the northwestern portion of Alabama, we have a number of cover crops growing, or a number of producers growing cover crops, and those are a lot of the producers up there have moved into rotations with corn, soybeans, and cotton, as well as some winter crops of wheat and canola. And then South Alabama, we would have, those would be predominantly peanut and cotton producers with some corn and soybeans as well. So we do have a need for conservation systems, and I think that's why we do have some fairly good adoption, especially of conservation tillage, and an increase in, we have around 9% of harvested cropland and cover crops right now, but we definitely have room for improvement in there. So with that, a little bit about the history of research and the adoption by producers in the Southeast. In 1896, the old rotation at Auburn University was started. It's the oldest continuous cotton experiment in the world. One of the objectives of that was to test the effect of winter legumes in cotton production. At the time it was started, it was more of a mulch crop instead of a traditional cover crop as we think of today. In 1996, that changed to be conservation tillage, so it went to a very traditional, what we consider a traditional cover crop. And it's always been a legume, so either hairy vetch or crimson clover. In 1950, there was a paper out of North Carolina, the experiment station there, talking about the effects of winter cover crops on soil properties and yields in cotton, peanut, and corn. And that's one of the earliest papers I could find on cover crops. And then in 1978, they had the first annual Southeastern No-Till Systems Conference in Georgia, and that continues today. And that conference A producer at that conference actually was quoted as saying, planting a cover crop is a minimal expense as compared to the dollar returns we get each year from this cover crop. And so profitability of using a cover crop was a concern in 1978, and we're still talking about it today. So research and adoption has continued across the Southeast, and that brings us to today, where we're going to talk a little bit about the barriers that are limiting the continued adoption of conservation tillage. Maria touched on these really nicely, so I'm going to go through them fairly quickly, but we have crop rotations here that are specific to the Southeast. All of these barriers have an economic component that goes with them. So in this case, we can grow winter cash crops, so we can double crop, and people have invested in crop-specific equipment, like for peanuts, where there is some soil for digging the peanuts, there is some disturbance of the soil. Also, we have soils that are prone to compaction, so there's machinery and labor costs that go into addressing that. So with a movement to conservation tillage, you could reduce some of that. Weed pressure, the herbicide costs that go along with controlling the weeds, as well as where we have these herbicide-resistant weeds, such as Palmer amaranth. Hand labor has come into play, and so with the use of a conservation system, we could potentially reduce that. Also, perceived yield security tends to keep people from adopting conservation tillage, and that goes directly with a perceived revenue security. So my concern that the yields are going to go down if they switch to a different tillage system. Cash crop establishment concerns, especially into high residue cover crops. They are concerned about plant population numbers. Isn't as big a concern with cotton and soybeans because they tend to make up for lower plant populations, but it definitely is a concern for producers when they're talking about their corn. Also concerns about replant, and then directly related to their profitability. And then producers, especially depending on what kind of fertilizer they're using, if they're using poultry manure, which is fairly common, there are some questions about how to incorporate their fertilizer and or herbicides in a conservation tillage system. So as it relates to barriers for cover crops, they're similar to tillage, or conservation tillage, but they're a little bit different. So one of the most common barriers that we see here is the question about time and labor. How am I going to get my cover crop in the fall if my cotton harvest or corn or soybeans gets delayed and I'm looking at November for planting our cover crop? Also the input cost related to it, the cost to buy seed, and also the time it takes to terminate it in the spring in order to be able to get their crops in, because we can plant so early here, especially in South Alabama. And so there is an opportunity cost of planting cover crops. Establishment success is machinery costs, labor costs, input costs, like how am I going to get it established, and what if it doesn't establish properly? Am I going to have to go back in and replant my cover crop? Seeding the right species, there is a lot of interest in cover crop mixes, and so we get a lot of questions about, well, you know, your research has been predominantly in single species. How do we know what we're really supposed to plant? And you know, how do they meet the objectives of their operation? Also uses too much soil moisture. The cover crop producers believe that the cover crop may use too much moisture, or it may hold too much moisture if we get a lot of rainfall. And that relates to uncertainty regarding the weather, also yield security, and then the economic return. And then just in general, the lack of economic return. And one of the things that we hear a good bit is, well, why would I plant a crop but not harvest it? And so that's why we've started really trying to look at biomass as a commodity, because if we're trying to get X pounds per acre of a biomass, then that is our commodity. That is our commodity as it relates to the cover crop. And then cash crop yield reduction directly relates to profitability. Maria touched on that really nicely earlier. Overall crop production risk, we see in our research that the use of cover crops reduces yield variability. So if we can get a consistent yield across the field with a conservation system and a cover crop, then that's going to increase the across the field profitability. Also, disease and insect potential. This really comes into play, I think, with our vegetable crop producers who are using conservation systems as opposed to plasticulture. And so they are concerned about how might the residue that's out there increase their disease incidence and also their insect potential, which would directly relate to the pesticide and fungicide costs, as well as the quality of the product that they're going to put before their buyers. So other barriers, tradition, that's a little bit harder to address, just that this is how we've always done it. Also weather, the lack of rain, excess rainfall, rainfall intensity. The picture here in the corner is actually was taken by Joel Love. He's with the University of Florida. This was last week. These are no-till Group 5 soybeans and a rolled rye residue of cereal rye and ryegrass. I thought it was a really nice demonstration of a conservation system here. Also, with it related to rainfall variability, in 2015 we received 14 inches of rain in a 2-week period. Even our cover crops had a hard time withstanding that amount of rainfall, and we did, as you'll see in a minute, take a little bit of a biomass hit there because the cover crops received a lot of rain and pretty intense rain as well. So how are we addressing these barriers? We have some previous research that we've done, and I'm not going to go into it a lot. All of our fact sheets are on our website, but we've looked into cash crop establishment using in-row subsoilers and modifying planters for high residue systems, as well as we have a good bit of research on how to terminate cover crops, both management considerations for the cash crop that comes after the cover crop, as well as a variety of rollers that have been patented of the best way to, if a producer wants to use mechanical termination with a roller crimper. Some of our research on weed pressure, because herbicide-resistant pigweed is such a big problem in the Southeast, a lot of our research has looked at how conservation tillage and high residue cover crops can address these herbicide-resistant weed controls. Some of our current research with weed pressure is looking at the impact of banded versus broadcast pre-emergent herbicides on cotton when they're grown in a conservation system. If you use banded, you may have lower costs than you would with broadcast. Also evaluating weed emergence in conservation systems with cover crop mixtures. That's some of our ongoing research that we'll be publishing in the future. So this is one of our current projects that I thought that this group would really like. It's looking at ways to, on time and labor and input costs related to cover crops. It's a 6-year experiment. It's a peanut cotton rotation, so it brings in that southeastern crop rotation aspect. It's down in the Wiregrass Research Extension Center in southeast Alabama. We're using just a single species cereal rye because that has worked really well in this area. We're looking at different planting dates, so you can see it runs from mid to late October all the way to mid to early December. 2 different seeding rates, and then we apply nitrogen to our cereals to help establish and really get that high biomass. And so it's looking at 4 different nitrogen rates. This is preliminary data for the first 2 years, and I've started looking at it from an average cost standpoint to produce that biomass. So as we move further into December, as we move towards December, our biomass goes down drastically. But and then obviously the cost is going to go up. So the cost to produce a cover crop, if you can plant early, is $1.80 per 100 pounds of biomass versus $3.90 per 100 pounds of biomass. So you can see that the benefit really is there when you're looking at minimizing your cost if you're looking at your biomass as a commodity. Also, we've looked at combining operations. So this would be for terminating cover crops and planting the following cash crop. In this picture, you can see we've got the planter on the back. In the front is a roller crimper, and then you'll see mounted here is a chemical applicator. So we would roll the cover crop, apply the chemical, and then plant your cotton. And we've really done this research in cotton, so these results are related to it. This is unpublished data as well. We're working on publishing it now. Looking at, these are our different treatments. I want to highlight the ones in green. So this would be planting cotton into standing rye, so it would be green. And then chemical application followed by a smooth roller, which would be combined with planting, and a smooth roller combined with chemical application and planting. So this is one application, one operation, and this is 2 operations, and this would be planting into standing rye. And as you can see, the standing rye just did not perform as well in cotton as chemical application separate with the smooth roller and the planter. So this is really great research, I think, showing that a producer that there's different ways that you can terminate your cover crop and lower your input costs and be able to fit it into the time frame that you need to. We've got several ongoing projects on mixtures. We've got a comparison between a single species and a 2-species mixture, looking at cereal rye, hairy vetch for cotton, and then cereal rye, crimson clover for corn, and then different nitrogen rates in the cotton and corn to look at to bring in that legume how much nitrogen it's putting out there. We also have a comparison between single species and 2 species mixtures and 3 species mixtures. We're using species that are very common, that growers are comfortable with here, and combining those together. And that's in a cotton soybean rotation. And this data is pretty recent. For 2016-17 growing season, this does have the biomass numbers in it, but only for the cotton. So it's 1 full year and then a cotton year on the biomass numbers. The ones in green are the ones I'm going to focus on. This is a single species rye, a rye clover, and then a clover radish. You can see the biomass averaged over the last 2 years. We had almost 5,300 pounds of rye, almost 5,400 pounds of rye clover, and then 5,300 pounds of clover radish. So those are pretty similar biomass. When you look at the cost, it ranges from 89 cents to 99 cents per 100 pounds. Then if you look at the coefficient of variation, I like to put that in there as well. You can see the rye alone had the least amount of variability across the study, followed by the clover radish and the rye clover. So this is a really exciting project because we've got the mixtures in there, and so we're looking forward to seeing what the results are as we finish out. This is a 4-year project, so we're in the 2nd year of this one. So 2 last slides, and it's important to remember, and this is what a slide I show producers when I'm doing producer meetings, that there are researchers and producers who have been working with conservation systems for years in the Southeast and across the nation, actually. And they're great resources for producers who are considering a conservation system. A lot of these producers are very willing to help other people, help other producers adopt these systems because they've worked so well for them. But adopting a conservation system is a long-term investment. It isn't a short-term investment. You may see some immediate benefits, but there are really long-term benefits that accrue over time, because just like soil degradation doesn't happen overnight, improving the soil health also takes time. There are agronomic benefits that result in economic benefits, such as reduced yield variability, but producers have to figure out the system that works best for them. What are their objectives? What are the challenges they face? And what are the goals that what goal are they trying to accomplish? And then lastly, I'm an economist on a team of 4, and so we do a lot of interdisciplinary research. Each discipline has a different perspective, and potentially we all have different data needs. There's a value to each perspective, and I found that being able to work together from the beginning produces a better quality output. So that output could be a peer-reviewed journal article, it could be policy, it could be fact sheets, it could be grant proposals. But working together from the beginning as a group really works well in coming up with a quality output. Also, while the data needs may differ by discipline, so I may need different data than, say, my weed scientist may need, the ability to collect the data depends on the available resources. So we really everybody has to have realistic expectations of the goals. How much data do we need to collect? How does that data relate to all the people involved in the process? So with that, thank you for having me, and I'll turn it back over to David.